Now, my students, let us proceed with the second property, which is used to describe a wave, and this is called time period. You'll be asked to define what is time period, and here is the definition. We have so many definitions, but let us start with the fundamental definition of time period. The time period is nothing but the time taken for a wave to complete one cycle or vibration. The time taken for the wave to complete one cycle or vibration is called time period. The time taken by a wave to complete one vibrations by a wave, it takes how much time. One vibration of a wave takes how much time is what we call time period. Now we can illustrate that one by using this diagram here. This diagram, we are going to explain what is period is. Now remember, for you to explain about time periods, in y-axis there must be displacement, in x-axis there must be time. That means a displacement time graph must be drawn. Now look here. For this diagram here, we consider this part from this point here, from this point to this point, this one here, to be a half of the cycle. But also from this point to this point, which is this one, half of the cycle. Again, from here to here back, this completes half of the cycle. From here again to here is half of the cycle. This is a half, a half, a half, a half. This is to say, in this diagram, we have two cycles. In this diagram, we have how many cycles? Two cycles. But again, a half of this cycle, half of the half is quarter. Therefore, from this point to the peak is quarter. From peak to then equilibrium is quarter. Therefore, quarter plus quarter, you get a half. Again, this is one. This is quarter of the cycle. This is quarter of the cycle. This is like also quarter. This is quarter. This is the same. Quarter of the cycle. Therefore, when you sum up all the quarters, you'll get two cycles. In a simple language, in these illustrations, I have two cycles. But what is time period? Time period does not talk about two cycles. Time period is the time taken by a wave to complete one cycle. Now, where is one cycle? This is a half of the cycle. This is another half. This is one of the cycle. This is one of the cycle. Therefore, time period is this time here. This is T. Now, is it, maybe let us assume if this is 1 second, this is 2 seconds, this is 3 seconds, this is 4 seconds. For our case, if you be asked to calculate time period will be what? 2 seconds. Because time period is the time taken by a wave to complete one cycle. Now, the one cycle I'm talking about is from this point, go back again here. But also, time period can be defined. Look again here. Look again here. From this point here, to this point here, we have a complete cycle. We can wonder how. This is quarter, this is a half, this is quarter. Quarter plus quarter, half. Half plus a half, 1. Therefore, from peak to crest, this is like a one cycle. Therefore, this is also period. Therefore, period also can be defined as a time taken for the wave to move from crest to crest. Look again also for the case of trough. For the case of trough. For the case of trough, look, this is from this way, this way. Now, this is quarter of the wave. This is quarter of the wave. This is a half of the wave. Quarter plus quarter, that means a half. A half plus a half, that means one cycle. Therefore, time period also is the time taken for the wave to move from one trough to the next trough, or from one crest to the next crest. But also look again, let us go back to this point here, which I was explained early, this one here. Do you see this point where we said this is for a complete cycle? One, this is a half, this is one. Yes. We can also define time period as a time taken for a wave to repeat its oscillation. Look, after here, the wave repeats its oscillation, because from here, this was the initial oscillations, which was passing crest, again passing down trough, going up back to pass crest. That means it is repeating to pass what? Crest. Therefore, time period is also defined as the time taken for a wave to repeat its oscillations. Therefore, this is the concept which we have under time period. I said from that point now we can have different definition. Time period is nothing but the time taken by a wave to complete one vibration. This is well and good. But also, time period can be defined as the time taken by a wave to move from crest to adjacent crest. Or time period also is the time taken by a wave to move from crest. This was from crest to crest, or from trough to trough. But this is according to transverse wave. What if we have longitudinal waves? In longitudinal wave, we have compression layer function. Therefore, we can define a time period as the time taken by a wave to move from one compression to the next compression, or from layer function to the next layer functions. This is also, we can have elaboration here as longitudinal wave. Remember, this is compressions here. Compressions. This is layer function. This is layer function. Again, compressions. Now, layer function. Now, the time taken for a wave to move from compression to adjacent compression is called period. Or the time taken for a wave to move from layer function to adjacent layer function is called what? Period. Therefore, this is how we can define period by using transverse or in terms of longitudinal wave. But also we said, what is time period? Also we said, time period is the time taken by a wave to repeat its oscillation. The time taken, look here, after passing through crest and trough, it comes again to trough. Now the time taken for a wave to come again, just to come again to crest, is called what? Time period. That's why we are saying time period is nothing but the time taken by a wave to repeat its oscillations. Mathematically, we can now define time period as follows. Mathematically, we can now come with time period as follows. Time period mathematically, I use black one. Mathematically, time period T is equal to time taken time taken for a wave to complete one cycle. To complete what? One cycle. Now, what if we have many cycles? Not one cycles. We have many cycles. For many cycles, for more than one cycles, for more than one cycles, how can we find time period? For more than one cycles, time period t is obtained by taking the time taken to move all those cycles divided by the number of the cycles. Therefore, the time taken to move the cycles, you divide by the number of what? The cycles. For example, we can have number of cycles, maybe n, which is 10 cycles oscillation, and the time taken to complete this 10 oscillation is 20. Now, what is time period? Time period will be equals to what? 2 seconds, because you'll take 20, which is the time taken, you divide by the number of cycles, which is 10. If you divide, you get 2, which is what? Which is time period. Therefore, this is how we can find time period mathematically. The other thing to note is the time period is denoted by the capital letter T. Time period is denoted by capital letter T. In describing a time period, we normally use capital letter what? T. But its SI unit is second. Is what? Second. Now let us go quick to the examples as time period concerned. Examples, we have example 1 here. Let us go quick here. This is the diagram which shows a wave. Now we have 0. It is starting from equilibrium to advances to a certain point. Now we have this one here. We have this one here, goes up, down, goes up, down, goes up, down. This is 0. This point is 1 second. This point is 2 seconds. This is 3 seconds. This is 4 seconds. Now the question is, calculate time period here. This is very simple. Time period is the time taken for a wave to complete one cycle. This is half cycle. This is a half. Therefore, this 2 is 1 cycle. Time period is this value here, which is 2 seconds. Therefore, for this example 1, the time period is 2 seconds. Example 2 is here. Example 2 is here. This is example 2. Up, down, up, down. Up, down, up, down. Look here. Now here, you have been given the value in terms of, here this is 2, this is 4, this is 6, this is 8 here. Now you have been asked to calculate time period. Time period is the time taken to complete one cycle, or the time taken between one crest and another crest. Time taken between one trough and another trough. I want to use crest to crest, trough to trough, because the value which I have been given, they are in terms of completing crest and completing trough. Now this is from here to this point is where we are going to look to find time period here. Now from this point, initially is 2, finally is 6. Therefore, how can you calculate time period here? Is the difference between this point. Therefore, time period is 6 minus 2, which is equal to what? 4. Therefore, time period for this case is 4. You can also use trough. From this one to this one, it is 8 minus 4, which is equal to 4 seconds. Therefore, time period is 4 seconds. This is how we can calculate time period. But also have the last example. The last example as time period concern. The last example as time period concern. this is in terms of question, is saying the time taken by a wave to complete 20 oscillation is 40 seconds. Calculate time period t. Time period t is nothing but time taken you divide by the number of oscillation. Time taken is 40 seconds. Number of oscillation is 20 oscillation. The time taken is 2 seconds. Therefore, this is how we can find the time period, either through graph or through words. Let us have a short break. We are going to come back.